So let me repeat because I just recorded. Before we talk about function, I want to remind you what is the relation first. So in 62, we defined the relation is a set of x and y, where x is the domain and y is your range. Right? That's it. That's a set of x and y. That's it. That's the relation. Now the function a bit more stricter, right? It say that a function is a relation, how and more, it assigned to each element to its domain exactly one element in the range. So this statement, this formal statement definition of function is that x cannot be repeated. Now, I never asked you to define definition or theorem or lemma or whatever on the exam. Never, ever. Because this is computational class. So all your exam problems is going to be computational. Okay, like problem, you solve it. So that being said, I don't want you to memorize this, but I want to understand it. So the definition of function is that it's a relation, and know that x cannot be repeated. Can y be repeated? Can y be repeated? I didn't say anything about y, so yes, right? So yes, y can be repeated, just x cannot be repeated. Where x is your independent variable. Y is your dependent variable. Now, when I say this, what do I mean by this? It mean y is a function of x. Okay. It mean y is a function of x. I mean, whatever I plug in for x, that'll be y. Right? So y depend on x. That's why it's dependent variable. You guys try 1A and 1B. I'll give you like half a minute. See, tell me, is it a function or not? What do you think? 1A? Yes, right. 1B? Because you have one twice. I'm looking for something I can pull it up. Can't find it here. It should be here. I just taught it last semester. Anyway, all right, move on. Right, so let me show you an application where it is a function. Let me show you two examples of real life example of a function. Birthday or birth month. Let's talk about birth month. You don't have to tell me your date. I'm September. I was born in September. How many you born? January? April? May. All right. So is it a function? Names being X and then birth month will be in Y. Is it a function? Yes, right? Somebody else can. Somebody who else September? Is anybody here September or May, April? Was it January? 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 Yeah. See. What's your name again? How? Bao? Bell. Bell. Yeah. Sorry, Bell. Bell has the same birth month as Ella, but it's okay, right? Y can be repeated, right? As long as X is not repeated, then you'll be then you'll be okay. Another example, if it's not a function, say I have, say everybody have one phone numbers, right? One phone. I have two. I don't, but I'm just saying I have two. So X being phone numbers and Y being names, is it a function? Is it a function? No, right? Me, I got me and then phone number of phone. Here I got two, so Mimi got two. Say Bell one, right? And then L. How do I? Ella one, and then everybody get one. So it is not a function because I have two phones, right? Repeated. Number of phone being repeated. So that's a real life example of whether it's a function or not. All right, now we evaluating the function. Given f of x equal x squared plus 2x, I want to know what is f of 0. So here you plug in the input and you should have an output. It's no longer a letter, it's no longer a variable, it's give you number. For example, in this case, it will be 0. So that means I'm going to plug in, let me reuse black. I'm going to plug in 0 for x. So everywhere I see x, that will be 0. Which is 0. You gotta do the rest and tell me what you got. Let's see. Y equal. What you have? F of 3. Very good. So 3 f of a. F of a. Yeah. Really just, and f of x will be I'm sorry, f of negative x. That will be x squared minus 2x, right? All right, so that's pretty easy. Number 2, what you see here is called a piecewise function. It's just like the name, a bunch of pieces pieced together, right? Bunch of graph pieces together. So unlike polynomial where it's smooth, if I graph a polynomial, it's smooth. There's no gap, no jump, right? No pointy. But for piecewise functions, there's gap. So for example, let me maybe I'll graph it on decimals for you to see. Y equal negative x plus 1. And I need to restrict the domain. We from -1 to 1. So look at that. It looks like that. Okay, so it go from -1. Why? I don't like it when it have the little dot here, but it's not here. It should have oh, that's when it touched the 1. Okay. Let me do one more thing. So that you can see. All right. Okay. So that means this is linear function, right? Easy. And then the restrict domain from -1 to 1. You can include -1, but not 1, right? Because less than or equal to 1, and then less than 1. So that means at the end here is the solid dot. That means included. Here it should be hollow dot. See if I can make it into a hollow dot. I'm not sure. I guess not. I don't know how, but I guess not. I don't want that. How do I get rid of this? All right. All right. Another one is y equal square root sqrt x minus 1. And then what's my restriction? I gotta do restriction. It go from 1 included 1 to 5 and included 5. So right there. So this should be solid dot here because the 1 is being included in the second graph. It should be solid dot here. Come on, give me at that point. 5, 2. Five, 2, and then 1, 0. I just want to show you. Okay, I just want to show you. So that's a piecewise function. This one piece is another piece. So let's fill it in. What is f of 0? Go back here. F of 0. I want to evaluate f of 0. Imagine you haven't seen the graph yet. Of course, you can eyeball the graph and tell me what's the y, right? Go back to the graph. F of 0, yeah. F of 0 is 1, right? You can eyeball the graph, but say you don't know the graph. F of 0, why is it 1? How do you come up with 1? It's not the answer, it's the how. I want to know. Who's answered it? Is it you? Oh, you spoke. Plug it into which one? First one, second one? First one, right? Very good. F of 0, so it's in between -1 and 1, right? So you're gonna pick the right function to plug it in. In this case, I'll plug in the first one because that's where 0 belongs to. So minus 0 plus 1, so 1. What about f of 2? What do I plug in? Yeah, the bottom one. Yeah, the bottom one, right? So square root of something minus 1, or something now is 2. 1 again. Right, so you're gonna know where to plug in, depend on which value is belonging to which domain. All right, talk about domain and range. Domain is the set of all real x values for which y is defined. So that's a formal definition. Now, for us, when I ask you for the domain, mostly we're looking for the value that make the function undefined, right? And then we say, okay, the rest is defined. Just this one does make function go crazy, right? So we don't want that one. So that's the domain, and domain is always your independent variables. Okay. And the range will be the set of all real y values. This means your height. For me, I think of domain is the width of the graph, and the range would be the height of the graph, right? How wide it go and how far it go. Right? That's how I think of it informally. So let's find the domain and range of this function. Is the polynomial. Then polynomial is the easiest function. What's the domain of polynomial? Any polynomial. All real number. Right? Any value you plug in for x, it makes sense. Because you can find some, you can ask yourself, what is the value when I plug in x? This is undefined. None, right? So it has to be everything. So domain is negative infinity to positive infinity, or you can write script r. I mean the set of all real number. For the range, you need to take a look at the graph. I'm gonna show in decimal first, and then maybe I'll show you how to do it in calculator, because that's what you're gonna use on your exam. Go away, go away, go away. Plus 4. All right, so let me explain a little bit. Oh. Here, so that's the graph. That's the parabola. Shipping point up. So let's talk about the domain first. I know you know that polynomial has all real number domain. By looking at this graph, how do I determine my domain and range? So again, domain is the width of the graph. See how far it goes, right? So what I want you to do is take the value on the x-axis and project it to the graph. See if it touches the graph. So let's do it. So to the left. Of course, the two branch is gonna what? It's gonna get wider and wider to infinity, right? So let's take this one. Did it touch the graph? What about this one? Yeah, everything, right? Of course, it's gonna get wider and wider. You don't see it, but it's gonna get wider and wider. Same thing with the right hand side. You can always touch the graph. So that means the domain is all real number. What's the range? The range is the height. Remember, the range is height. So when does this? Yeah, where does it start? Start from here, right? Oh no. Again, you pick a value on y-axis, project it over. You can always have a couple graph. That'll be your range. So range. Where's the range? That'll be am I included for? Yes. If am I included bracket or parenthesis? Very good. Very good. So, okay. Let me put a little note here. I'll remark. All polynomials. Plurals. Doesn't have that's x cubed plus 2x squared plus 5x plus minus 1. It's still all real number. Okay, you should be able to tell me right away. Number 3, number 2, what's the domain? It's rational expression, so x cannot be. Yeah, 2. or interval notation. Can someone tell me in interval notation? If you doubt yourself, draw it out. So anything but negative, I'm sorry, anything but 2. So I start from what? Yeah, negative infinity up to 2 parentheses. That means I don't include 2. Union 2 to infinity. Range. Range you have to graph. Range you have to graph. Graph here. Do you want to do in decimal or you want to do in graphic calculator so that you can practice on the exam? Graphic calculators. I prefer decimal, it's just easier for me. But sake of the exam here. Okay, so I want you to go to y equal, the very top left, y equal. Clear that. What is the function? Can you is it 1 over 3x minus 6? Now for the newer TI-84 plus, you can do fractions. You see the alpha and then frac. So you have to press the alpha first, then press this button, then it gives you fraction. If you don't have fraction, you have to do you have to do this. Say 1 divided by, and then parentheses. Okay, if you don't have the parentheses, it's gonna read differently. 3x minus 6. If you don't have the parentheses, it's gonna say 1 divided by 3x, and then the whole thing minus 6 instead of under the denominator. So 1 over 3. Oh, by the way, the x will be this one. Okay. See x, t, theta, and n. 3x minus 6. Let me delete that one, clear. And then you hit graph right here. Graph. And then if you do zoom stick, see anything different? The same thing. Zoom stick is gonna adjust the graph into the best window that you can see. Right? Zoom 6. But in this case, we didn't have to because it's already kind of nice. I kind of don't like mine a little bit because they don't have a tick mark on your graphing calculator. You should have tick mark. So right here, it should be a vertical asymptote. Guess what the values? Huh? No, right here. 2. Why 2?
That's what it.
Yeah, that's where it's not supposed to be. That's what happens to the graph. It go. Excuse. Bless you. Go from negative infinity to 2, and then all of a sudden it just shoot down to negative infinity, right? Because it's not supposed to pass 2 or even touch 2. Same thing with the right hand side. Is start to the right of 2, never touch 2, and then go to the right from that end. So the domain will be from, can someone tell me the domain? Oh, we already did the domain, sorry. What about the range? By the way, if you zoom this in, this blue line should not touch the x-axis. It's kind of difficult to see here. It never touch. You keep zooming in. It's never touched the x-axis. And then I'll go back to zoom 6 again. So what is my range? Again, start bottom up. That's the height. So it looks like negative infinity, right? Up to 0, right? It doesn't touch 0, but get very close to 0. And then it skips 0. It go from where to where again? 0 to infinity, right? So let's roll down. So it go from negative infinity up to 0, doesn't touch 0, is union, skip 0, then above 0 to infinity again. Can you do that on the exam? Number 3, I want you to try on your own. Yeah, try on your own. I'll walk around, see how. Use a graph. If you use a graph. Let me show you how to do this. And then you tell me the answer. Okay. So why go again? Maybe delete that one, clear it out. Cube root. Does anyone know how to do the cube root? You go to math. Right here, math. Math. And then go see the 4th option. So you click number 4, but you can go down with the arrow, but I'm gonna click number 4. So cube root of, what was that? Was it x minus 8? Thank you. X minus 8. Graph. Some 6, still the same thing. Those are just points, the little thing there. Just point. Let me do zoom 0, see what happened. Zoom 0. Yeah, I think I like zoom 0 better. Depend. You can adjust your window as well. You go to window here and then adjust it. Maybe to go to Windows here. I'm gonna like zoom 0. I think zoom 0 work better, at least on mine. Not sure about you. All right, so what is the domain? Domain is the width, how wide the graph stretch. Huh? Everything, right? It looks like everything, like everything. What is the range? How high does it stretch? Huh? Yeah, everything again, right? So so the cubic graph pretty easy going. The one that you watch out for is the square root one. Okay. So I'm just lazy. I don't want
So it's always like that with a
cubic. Yeah, unless you have a unless you have a fraction. Right? So don't write this down. I'm not gonna make do this in your exam. Maybe something like that. Then the top is all real number, but then the bottom is what? Negative. Yeah, everything but 1. But the square root is the one you watch out for. So I suggest you practice on the square root. Might be on the exam. All right, so here is an application. So this is the application class. So I try to put as many as application in the lecture as possible. So here is one of the applications. It's more like critical thinking. I wanted to compute the height of the column below. What should be the restriction? So the application of a domain is that when we talk about length, it has to be what? It has to be at least 0, right? Can't say I run like -2 miles, right? Can't say that. So the restriction here is that whatever length I'm giving you, because it's in variable, that means I can plug anything for x, right? Again, this is a polynomial. I can plug anything for x and it still makes sense. But because this is application, x has to be what? Because this is application, 5x minus 10 has to be what? Greater or equal to 0. Maybe it's greater than, because apparently you have some length here, right? But let's just mathematically just say at least 0. So that's the restriction. And then you solve for x, you add 10 both sides. That's cancel. So you got 5x greater or equal to 10, divide both sides by 2. X. So that is your domain, right? X has to be at least 5. Bless you. Yes.
Would that be x is greater or equal to 2?
Oh, I'm so sorry. Oh my God. Thank you so much. I think ahead. I think I divide both sides by 5. Jesus. Thank you so much. I got ahead of myself. So that'll be subtract 1 point for me. I thought ahead of myself. Thank you very much. So I can be at least 2. So far, so good. Yeah. Still recording. That's good. Okay, so the vertical line test is actually is based on the definition of the function. Remember, what I want you to remember from the definition of a function is that well, just one thing. You don't have to remember the whole thing. It's just one thing. X cannot be repeated. That's all I want you to know, right? So maybe let's do this one. I have a function y equal to x minus 3. And I claim this is a function because for every x I plug in, there's only one y. That means it only x is not repeated, right? And what I can do is, maybe I'll give you another example. Maybe I should give you another example. Maybe I'll use red. Let me use red or blue because we already have red in there. You tell me, is this a function or not? Is this a function or not? Very, very good. Why? Bless you. Yeah, I mean x repeated, right? So if I told you when x equal 4, you project upward. There are 2y, right? So so 4, say 4y and y1, and then another 4y2. It could be any value. I don't know what it is, but so x repeated it, right? The thing here is x is repeated. That's bad. Not a function. Now, if I draw a vertical line test, let me do in red. An arbitrary vertical line test anywhere. Maybe I'll choose this one right here. This is arbitrary. Okay, you can move. You can. Somebody else can do it right here. Somebody else can do it right. It doesn't matter. How many times does it cut the black line? It's 1. How many times does it cut the blue one? Twice, right? So the vertical line test is that in order a function. I'm sorry. Yeah. If if a relation is a function, it's only allowed to test the vertical line test at most one. At most one. And more than two, more than one will be not a function. So should I write something else here? I thought I put something so I can write it. So vertical line test. I don't know what the best English way to say this. Maybe cut. The most ones. Right. So let's do some problem. You tell me is it a function or not. Number one, is it a function? Yes. Pass the vertical line test. Okay. Number two, no. Three, no. Four, yes. Yes. That's it. That's all vertical line test is. Okay. This is something that you see on the exam. I promise. Like this example. Use a graph to answer the question from A to F. That's the graph. F of F. I want to find F of 0. So x is 0. When x is 0, what's y? 4. Thank you. Okay, the first one is easy. Don't mess it up. That's 2 points. Find the value where x. Find the values for x when f of x equals 0. The height is 0. What is the x value that corresponds to the 0 height? Yeah, 4 and 4, right? So x equal. But thank you both. Find the x-intercept. When I'm looking for x-intercept, I'm gonna set y equals 0. And you know why? You know why, right? For example, I think I just eyeballed this here, isn't it? I don't have to. I just eyeball. I don't have the equation for you to do that. All right. What is x-intercept? No, it's the same thing, but it's not the same thing. You're gonna write correctly. I may. Okay. Somebody write -4 and 4. 1 out of 2 point on the exam. Why? Because I want points. I don't want coordinate. Right? I'm talking about point. So yeah, -4, -4, 0, and 4, 0. Y-intercept. Thank you. Thank you both. 0, 4. That's not 1. Domain. Domain of that. Domain. Domain will be the x, be the width. The width. Yeah, -4, 4. Does that help you when I say width? Yeah. I don't know. Is -4, 4. Bracket, parenthesis. What do? Both, right? Because I include -4 and 4. Range. Height. 0, 4. So bracket 0, 4. Bracket. So you can, yes, Bell. Bracket means you include the values. Yeah.
So is that the same thing as like the outcome that's solid numbers?
Yeah, that's the same thing. Solid point mean you include,
Yeah.
hollow dot mean you not. Yeah, same thing. And if I know how to spell parentheses right. Did I ever say it right? Or should be an E here or A? E, right? Should be an E. Parenthesis. So you when you're home, you read my notes, you see it. Wow, we done. We done early. Okay, before we leave, let me say something, and then I'll let you go. You still be out early. We have, let me take a look at the syllabus. I'm slightly behind, just slightly, not too bad. So we finished 2.3, yay. Next time we're gonna do 2.4, so we're okay, right? We're gonna have a quiz 1 on September next Friday. I'll send out an announcement to tell you what to study. Okay, so don't worry about that. The quiz probably have like 2 or 3 question max, because only like 10 minutes. I cannot give you everything. And then after that, you have exam 1. All right, have a good one. If you have any questions, please let me know. Otherwise, have a great weekend. See you next week. Yeah, thank you.